Who have heard of 5G before? Okay, good. That was an easy one. Who have seen the functional architecture for 5G? Oh, quite many of you. I'm going to show it to you anyway. I have a point with this. This complicated figure, as you see, and most probably some of you know this, this is from the 3GPP standard. 3GPP stands for the 3G partnership project, which was basically when we started in the telecom sector doing standardization between functions. And I say logical architecture, and that is a very important point here. You see boxes, and those boxes we call network functions. But those boxes don't correspond to implementations. You can implement those boxes as, a piece of hardware. You can implement those boxes as a piece of software. You can implement those boxes as a, piece of software that was made for the cloud and is running on the cloud. So all kinds of mappings are possible. I think the point with the functional architecture is that this is the blueprint for multi-vendor interoperability. So if there is an operator who would like to source a network, they can buy these network functions from different vendors. And these network functions have interfaces between them. Those interfaces are the multi-vendor interfaces. So someone buys a 5G core, and they buy half of it from, let's say, Nokia. The other half they buy from, let's say, Ericsson. These are the interfaces in the functional architecture that both vendors need to adhere to. So when we put together these network functions, they work. But again, don't view this as an implementation. In practice, we can map many of these network functions into, cloud software. In fact, we at Ericsson kind of map many of these network functions into sort of the same software. So one piece of software implements the multitude of these network functions, but of course, all of these interfaces are provided for multi-vendor integration. And the reason I'm showing you this is because in the 5G standard, also known as Release 15 of the 3GPP, and at the bottom you see the link to a very thick document describing it all. We differentiate between of these multi-vendor interfaces. Some of these we call service-based interfaces, and some of these are non-service-based interfaces. What does this mean? For the blue part, for the service-based interfaces, we implement something that might sound very cloud native to all of you. We have service discovery. We have services that find each other, and then there are service producers and service consumers, and they interact with each other. All the communication is done over HTTP2 and is API based. So it's a very nice, friendly way of communicating, even in a cloud native setting. Something I haven't said before, but we at Ericsson, we do implement the network functions in a cloud native way. So these are actually microservices running on top of Kubernetes. But you should imagine like NSSF or NEF or NRF. These are the network functions, and in the background there are many, many, many microservices, pods and containers implementing these network functions. So how about the non-service-based interfaces? Well, here we have a little bit of a problem. And when we started off by saying that we need superpowers for 5G, and superpowers in this specific case should be coming from NSM, we need NSM to cater for the non-service-based interfaces. If you look at the picture, the top of the picture is more or less the core network. The bottom of the picture, you start to see things like UE, which is the user equipment, also known as your mobile devices. You have the RAN, the radio network. You have the UPF that takes care of handling all the data plane. So imagine all your mobile broadband traffic within a country in an operator goes through that UPF or those UPF nodes. So those network elements or network functions communicate differently than the top with the service-based interfaces. And many cases bring specific requirements to the table, and those requirements are not always easy to be fulfilled in a Kubernetes environment. Also, it's worth noting that since things at the bottom handle quite a large amount of traffic, it is usually good to use some sort of hardware acceleration for those network functions. So looking at a little bit at the use cases, you see a nice table, and that table is trying to sort of summarize the kind of different traffics that we have in a 5G setting and classify them depending on whether latency matters for those use cases and whether there is inherent security provided in the transport layer or somehow else for these protocols. When it comes to the non-service-based interfaces, we have, unfortunately, the need to provide things like non-standard transport protocols like SCTP with multi-homing and path diversity. There are certain protocols that don't tolerate netting, and you probably know in Kubernetes the default way of doing load balancing involves netting. Well, we have protocols like SIP, which will absolutely break if someone messes around with the IP addresses. And there are certain protocols that need pure layer 2 connectivity. So not easy to fulfill these requirements in a Kubernetes environment. These can be fulfilled, but in quite many of the cases, you need some sort of an orchestration beneath the Kubernetes layer, and that usually never helps the portability of the application. Then, of course, we have to take into account how our customers, how the operators work as of today. In many cases, they use layer 3 VPN separation for the different kind of traffics. So for O&M traffic, for service-based traffic, for charging traffic, for lawful intercept kind of traffic, they all have their specific layer 3 VPNs. One reason is to provide additional security for some of the protocols that don't support security. Another reason is that they have a standard way of working as of today, where they can have the IP address planning independently for these different traffic types. So when you have a large network, you have several teams working on those large networks. And of course, it's easier to do IP address planning if these teams don't have to necessarily coordinate with each other the IP address ranges. So in many cases, for these traffic types, we have overlapping IP address ranges. Then, of course, we understand that when we deploy 5G core and 5G, that usually goes into an environment where you have 4G and 3G and 2G and God knows what else. I think some operators still to this day need to support telex service. So who have heard about telex service? No one, it's just me, I'm super old. Anyway, so we have to deploy these cloud-native applications into environments where we have all sorts of legacy VNFs and physical network functions as well. Those naturally have their way of communicating, and those will not change just because we decided to do cloud-native for 5G. And even if all of those could change, operators normally have roaming partners. Roaming allows you to use your mobile phone across different countries. So it doesn't help if one operator decides to change all of their networking to be super modern and cloud native. If their roaming partners don't change that and they still require legacy protocols, a legacy way of working, we have to adapt to that. Last but not least, again, I call the attention to the need to have hardware acceleration, because there are certain network elements through which all of the mobile broadband traffic goes through. So all of the YouTube, all of the Twitch, all the Facebook and everything goes through these network elements. So they need super high bandwidth and super low latency to live up to the expectations. So any questions so far? Yes? Yes, we do. We actually have both control plane and the user plane in a cloud-native format that we are going to release during middle of 2020. So we will have an implementation also for the user plane that will be cloud-native.
And just to follow up, would it be across the RAN or just in the core?
Well, the UPF is part of the core, and it interfaces with the RAN directly. Now, it of course also depends on where do I deploy the UPF, because I can deploy the UPF in the national data center or global data center, but we see that for many of the use cases, the UPF will be deployed closer to the end user. So it might be a regional data center or an edge location. In any case, the UPF belongs to the core network. But as you see, when it comes to its interfaces, those are non-service-based. So these are non-HTTP2-based, non-API-based interfaces. And anything that interfaces with the radio according to the standard is not service-based. Any more questions before we continue with Henrik? Good, then I leave the word to you.
Sure, thanks. So if we leave a little bit the networking for a while and look how the deployment scenario looks in a telecom context then. So of course, in many cases, we are able to set up our reference stack, meaning selecting hardware, the Kubernetes layer, the castle with some additional services, and then running our cloud-native applications on top of this. But actually, in many scenarios, this is a split responsibility because the CNFs might be, or the cloud-native application might be actually provided by one vendor. The customer might select that they want to provide or get the calls from another vendor, and at the end, it's actually the telecom operator that is managing and operating this. So of course, there's a very different split of responsibility here compared to if you see a typical IT or if you run it as a service to someone else, where you can actually have full control of, you might run in a public cloud, but then you have full control of all the layers above. And I think this is important to understand when we also look into NSM and what we want to achieve, or what we see that NSM can bring. So what we want to define for this, to have our cloud-native application to be able to run on these different layers, is to have some kind of standard, a very thin COS layer for our cloud-native application. What we're looking at right now is to see what kind of CNCF projects or whatever that is to be included here. Of course, it's a certified Kubernetes with some more additional agreed components like Helm or CNI plugins and these kind of things, as well as what kind of characteristics that are expected from this COS layer to make sure that we can actually provide what we want to need to provide on the CNF layer here. So if we try to then connect to this kind of superpower that was in the first slide, I think this was already explained, and I think this is already well defined by the NSM, but still, we think this is an important aspect. So it is this kind of abstraction and declarative approach to express this kind of network needs that we see in these more advanced scenarios that Thomas was providing. And of course, it's a well-defined, structured way to do this. And also that it doesn't really focus on how it's done, it's more you express your needs. And I think this is very much in the spirit of how Kubernetes is also doing other things. And what we're really looking for is to have this kind of industry alignment here, to bring alignment, how to address the kind of different advanced network areas. And as you saw on the previous slide, that actually, how can we get NSM as part of this thin COS layer? So we can expect to have it always there, and then we can express our needs from above, from our applications. And I think to really achieve that, of course, NSM is as we see it right now, it's a powerful framework. We can do all these kind of different plugins to do a realization or implementation of different things. But as you saw also, when we have this kind of split responsibility, we would, of course, what we see where it can even add more value is that you have at least some default plugins or services that will provide some of these kind of typical use cases out of the box. So we will maybe express just that we have a need to have a VPN to this external entity, whatever it might be. And we don't really have to provide those services because that's the responsibility of whoever included the NSM in that thin COS layer. So these are the things that we see, and of course, the NSM can of course involve and add more things, but I think this is what we see that really could make this area a good alignment from our point of view. So I think from that point, I'll leave over for a small demo on some of the things we've done.
Yeah. So we made a small demo. It's like more like a toy thing. It's because we wanted to learn NSM as well and to find out the eventual gaps, what we need to do. So this is a kind of a cool, it's actually, I think it's fun. So what we did, we took the bridge domain service in the examples directory, we added an OpenVPN server to it, and we activated the load balancer that's part of VPP, the LB plugin. And then we have an L2 network then to our applications. And with this, we can sit like externally, and we can get into the Kubernetes system using a normal Kubernetes service for the OpenVPN port. So this will be this is the overall the system view of it, and this is how the actual service is looking. So yeah, it's based on this bridge domain stuff anyhow. So maybe I should look a bit at the demo now then, and then we can go back to this presentation later on. Because so here you can see I already installed the system because I sometimes have problem to get Cilium up. So if you look at the services, I have here an OpenVPN, which I run as a node port. And in this window here, this is now external in my laptop, so I can get a connection to the system. I get the VIP address here, pushed as a route. And then this is the NSM network. And then I will also go, I can go here, maybe. CD. No, I couldn't do that. I can show that in the picture instead, which I also have screenshot. So here is the same picture more or less, but the clients, because I had to mess up something. So this thing is not really like, I wouldn't say it's a clean NSM way. I had to change the protocol of NSM to add the information, because the load balancer adds a GRE tunnel header on top of it. And I didn't want to add the GRE tunnel in the clients, because then they would not be privileged. I mean, so instead I added some data to the protocol where I could flag that this data going is on the tunnel, and then I changed one of the converters for kernel interfaces to add the GRE tunnel, and it also does source routing on the VIP address. So this, what's called VIP 0 here in all the clients, it's actually a GRE tunnel, just to get replies on the VIP address. The NSM interfaces are sitting here. It's on an L2 network. And then we can go back to the previous screen. kubectl get pods minus wide. So those three guys here are the applications. You can see what they ends with. And then I can go from external, and I can ping those. And I can now I get the same one. They're different. Yeah. Here you can see that all three pods answers. And this is load balance. It's not NAT. It's what we actually need. So, I mean, the packet is completely untouched on the way from the client to from the external client to the internal client. So maybe I can go back to the presentation again, because yeah, when doing this, then we saw that I have an unstructured list of things that we can look into for the future. For instance, we would need to have multiple interfaces in the container, and that can easily be done using the dynamic configuration of NSM. But since we have a lot of legacy programs, we actually want to modify the init container so you can do annotations for multiple services with that one. And then we noticed that if we crash, if we restart the service, I assume a close will be called in the protocol, but the init container doesn't care about this. And since we have state in the services for IPAM and stuff, to get the system running again, we actually would like to restart the client pods if the service disappears, if there is a state dependency between them. That's one thing. We think we will need to look into to have the data plane in the smart NIC, which I think would be very easy if we could find the smart NIC with VPP in it, because we could just use the VPP agent protocol to configure the NIC probably. And that is for the data plane. We're also looking into something else, because most of the services we're looking at isn't doing anything with the packets more than like reconfiguring stuff. So it would be interesting to see if we could have like a virtual VPP, like a delegation of the real data plane VPP. Well, I mean, what I'm saying that usually today, most services, they start by doing a reset on the VPP configuration, so you wipe out everything away. It would be nice if you could have multi-user of that VPP, so we could say reset, and it would be my VPP, but still down in the smart NIC. So if you say, I get like a request saying that here is the connection, here is your interface, that would be my interface, but I still don't have it, it's still down in the smart NIC. And I could tell that to connect it to a load balancer or whatever I want to do. Yeah. And then these pseudo services for defining external connectivity, that exists probably today, a way of doing that with this proxy NSM or something, I don't know. Yeah. So, but it's something. And then, of course, in the long run, we would like to see an ecosystem of services. So when we deploy in the public cloud, we can just give a list of our requirements. And because I still see that the services probably will need to be privileged, but our application should not be privileged if you can have it good. And then we're looking more stuff. I mean, maybe XDP would be interesting. I looked at the MEMIF is a very good interface, I think, but it seems tied to VPP. And when we try to run with the kernel data plane, there is no MEMIF. So probably we could have an XDP that also has like shared memory rings and get the same characteristics. But this is like a few things that are not so structured, but it was what I was thinking about. I don't know. Do we have anything more to say about this?
No, but maybe we have questions from the audience.
Yeah.
So it seems like you've got the basic connectivity of these non-service protocols. Do you have any ideas where to go next, like how to handle protocols like the amateur is not a service protocol? What happens when nodes go down and you have to, how to adapt these?
How to adapt these legacy protocols into a service architecture environment? Do you have any ideas how to take leverage like the best of both worlds?
Okay, maybe.
But to start with, we need to implement the old ones, because when we come with the system and the customer says, we don't want to redo our network, then we need to be able to support the old diameter. But then for the future?
I think for the future, it's a very hard question, because if we want to change the legacy stuff, we have to go back to standardization. Then if we go back to standardization and change these things, would actually the vendors, all of them, be re-implementing this functionality according to the new standards? And would all of them be doing that? And would all of the legacy functions be changed in operator networks? So, many ifs on top of ifs on top of ifs. It's not likely. I think it's more important to find cloud-native ways in a cloud-native environment to be able to handle the non-cloud-native protocols and stuff.
But then the question is, why bother? I mean, if you're not leveraging the benefits of cloud, why go to all the length of moving to a cloud-native architecture if your protocols still limit you?
Sure, and I think the answer to that is, of course, not every legacy stays in the network. Some legacy operators get rid of. But I think an even better answer to that is, if we look at what NSM does today in this setup, it helps us to handle the legacy protocols. But of course, this might not be the technology that we go live with and the operators go live with in the middle of next year. It might be something that is proprietary and we have done until we can sort out all those questions with the NSM. At the same time, we would not like to use that proprietary logic that we have implemented now. We would like to replace that with something that is more coming out of a community, and then we can sort of refer to that and help maintaining that open source piece of software where it belongs in the open source space. So it's a little bit of we need a technology that let us use the legacy things in a cloud native setting, and we would prefer if that technology would come from the open source community, and that's why we are here.
Thank you.
But it's also a thing, some of the things we have, I mean, we have interfaces that have such a hard latency requirement. So some of the radio guys, they say that this interface, this is not a problem. It's really relaxed. So you ask them, what is it then? 30 micro is saying. It takes 30 micro to switch one process in Linux. I mean, and that is the easy things. They have harder interfaces as well. Yeah. And you need like to send them out at exactly regular points. You cannot send it too fast and cannot too slow. So, I mean, it's also good that with Kubernetes we get one way of orchestrating the system, even if we have some pods that will waste a complete blade or something like that.
As far as the network interfaces between the network functions, the multi-vendor solution that you all have, is there any way that just the interface could be implemented with using a license like GPL so that you wouldn't run into some vendor doing a change and then trying to do some type of embrace, extend, extinguish or something?
I'm not sure if there was a question in there
Yeah.
somewhere.
No, do you guys, as far as the interfaces between the network functions, just that portion, could you implement that as with a GPL license?
But, it's an interesting question because it becomes a licensing discussion between 3GPP and whether the GPL license would be suitable for that. I think what you're after is an industry standard agreement between everyone to use a given interface for interoperability. And that is in place through 3GPP as of today. And 3GPP doesn't stop at release 15. There is work ongoing for release 16. Maybe for release 17 we'll use a different license, but I think which license we use, that's largely irrelevant. The point is that we need to maintain a cross-industry understanding between the telco vendors and operators. So everybody is relying on these interfaces. So if someone doesn't play this game, they really can't compete because then their only alternative is the operator buy everything from me, and that doesn't fly.
It seems like if again, with GPL, it has to be public, so no one can really play the game.
But if you go to that link that is included in the presentation, which will be shared, then you can see the whole spec, the whole standard that is public, and anyone can access it.
Thanks for the presentation. It's really, really good and nice. I hope that some of these things we are going to see as contributions really, not just wish list.
Yeah, but we need to discuss with the community as well because maybe we are not going in the correct way. So we need some help with this stuff, I guess.
But
Small remark on the last one, because you said that MEMIF is only DPP. Recently, like a couple of months ago, maybe 6 months ago, it's part of DPDK. There's a PMD driver in DPDK.
So you can run DPDK on top of MIF? Or?
Yes. I believe that more capable people here.
Yeah, and that's good because that's what some of applications of course running DPDK, so they would need something to run DPDK on top of. But then MEMIF is extremely good when we go from process to process because we share memory. If you would have a smart NIC, how would you pull up that data then through the PCI bus to the application?
Well, you have to implement it in the Well, you have to implement something.
And of course, I think that this accelerated stuff, it's like maybe for 1% of our applications. So it's not like it's not the most important story. But if you don't have that story, we cannot switch to NSM completely. This is the thing. Then we would go with other solutions also.
I think the intention with this list is two things. One is to show you and the community of what we intend to do and ask your feedback. Does this fit into the ecosystem you have in your mind? Second, if you have been thinking about similar things, please come to us and talk to us. And we're more than happy to collaborate. And I think that one thing that you have said during the presentation, and that was the importance of hardware acceleration. I think that in the ecosystem that we deploy things, we see that SmartNICs will get a very important role, and we have to support that.
Yeah, we see that our hardware will come with SmartNICs soon, so we will have that.
Yeah, but we see that others' hardware will come with
Yeah.
SmartNICs, so it would be good to, take advantage of that.
And then I can also recollect back to the discussions we had with OpenStack, because it's a VPP can be very quick if we assign it a couple of cores and put it into a polling loop. And that we did with OVS, and we get a lot of people internal in the company that says, you cannot waste 4 cores here. And then you got all this discussion. So then by moving it down, it doesn't people doesn't get pissed off for nothing. Yeah.
All right, so
Yeah.
any closing questions?
I just one small remark, and I think that we should move to the next session. So there's nothing. So there is a very nice definition. We have already shown it from the technical committee, technical oversight committee from Cloud Native. There's nothing about protocols there. So legacy, new protocols. I mean, Cloud Native is not about protocols. I think that's one of the highlights of NSM. So protocols are kind of independent.
Mm-hmm.
Yeah.
Okay.
May I offer up a comment here?
Yep.
Sure.
So I'm looking at your future contributions, and you've commented in a few areas about some of the things you need. Have you thought about looking at, say, tungsten fabric in your solution? I mean,
We have
it
looked
already
at-
supports a multiple interface.
Yeah, I
that you
know.
need.
Even Contiv would like to do a lot
Yeah.
of it. The reason I like NSM is because it's like an open book. I know. The problem with all those solutions that exist is that they are very there are different group of people that wants to have it. It's more political thing, I think. For me, it's easier to come with NSM.
And I think there is even another reason, and that is we do software that will be deployed on top of the cloud that we build, and it will be deployed on cloud that someone else builds. So when we go to those environments which are out of our control, we have to present a list of requirements on the cloud towards the operators that please buy a cloud that supports all these things. We would like that list to be as short as possible, or maybe 0. So if NSM becomes the de facto standard across Kubernetes distributions, and it will be available everywhere, that's the easiest, and that would be the best for us. Second best, of course, if people understand what NSM is for, and it's a good thing, and they are happy to add to their Kubernetes distributions. So again, if we go somewhere with our software that meets someone else's cloud, then it's not an issue to deploy it. And of course, until that happens, we might have to package it together with our applications. That's the least preferred option.
So do I understand that if you go with NSM, it basically means you don't have to worry about anything underneath it? All of that stuff disappears?
No, we have to worry about we still have to worry about some stuff, but also NSM, what I think about NSM is that the thought is that you should actually let the application publish its service, and you should integrate the application with NSM. This is not what we are doing now. We are more building legacy networking, but NSM is also a path for the future, I think, maybe.
Yeah, I think it goes back to the picture I showed when we try to abstract and create clear responsibility separation here. So I mean, from an application point of view, which we in many cases would be the only thing we deliver, we would express our needs, and then if how it's really implemented, in some cases we don't really care. But of course, if we have the full stack, we still need to have an implementation there. But I think that's this kind of industry alignment that I talked about. I think is the key thing from that point of view.
Fair enough. All I would say is that if you've got expressed needs for multiple interfaces, then take a look at Tungsten Fabric. If you already want an agent and a forwarding plane and a SmartNIC, Tungsten Fabric's already there.
But we are running contrails in our, isn't that more or less the same thing? So, I mean,
Excellent.
but that's in our VM applications. Yeah.
Use it for containers too.
Yeah, I actually like the vRouter concept because it can, you have the forwarding outside. You don't have to go to east-west. The east-west will happen directly. Yeah.
I guess we're running out of time, right?
Turn it off.
Cool. Thank you very much. And just a quick note on the Tungsten Fabric thing. So part of NSM is that we want to allow you to bring in whatever works for you. So if Contrail has the primitives necessary that works for your use cases, we absolutely want to make sure that you're able to bring it in and use those particular things. So definitely thanks for bringing that up as well.